Okay, also in the back? Perfect, because when I stand in front of you, it doesn't sound like there's anything happening to you sound-wise. Yeah, let's talk about Ansible Development Environments. I will introduce myself shortly, and then we will talk about different solutions and demos, compare those in the end, and then we recap this with some closing thoughts. Who am I? My name is Niklas Werker. I'm from Cologne, Germany. I work as a consultant and trainer at SVA. We also have a small booth downstairs, so say hi. And I do mainly DevOps infrastructure automation. Before I started working in IT, I did some automotive engineering, and you can find me at Werker at GitHub, GitLab, or of course the Ansible Community Forum. What do we want to talk about today? So this is it feels a bit like this is my Trojan horse to talk about all these fancy flashy tools, and using Ansible as an excuse to talk about this here. But we will talk about this in an Ansible context, and I work with several clients with those tools in an Ansible context. But it's a bit hard to decontextualize all of this from platform engineering. I will try not to go deeper, but just know there's like a bigger picture and bigger integration possibilities that we won't cover today. Yeah, so one of the reasons I want to talk about this is I have the privilege to be a community lead at SVA, and this also comes with a lot of people coming to me and be like, hey, have you seen this flashy new tool? And then I try to understand this flashy new tool, and in the beginning I was thinking, oh, all of these tools are trying to solve the same problem, but they are kind of not. But they are kind of solving a fleet of different problems. And there's a high chance of falling down rabbit holes. So in prepping this talk, a lot of times I had to delete the project, start from new, and don't look too much deep into this, because we will just cover the very tip of the iceberg. In every technology and every tool we look at today, there's like much more. So yeah, before we dive in, keep it simple. Like, people have tried to use similar ways to manage their development environments before. Things like .files, things like Coder Server, that started around, I think, 2018 to 19, all of those kind of things. So it's very intriguing to do all of those fancy flashy things, but sometimes plain text editor is still the best. Sometimes. Your mileage may vary. So, conceptually, what is a development environment? It's a very roughly, not so much defined term. So you have a classic approach, which is you just install everything on your machine, and then you directly connect to all of your Git, to your infra, to your secrets, to your CI/CD, run Ansible directly to those hosts, against those systems. Maybe you use some kind of virtual environments to separate those environments, but this is like still a classic approach of managing those. Then there is a local development environments, which you use containerized solutions. So you have several development environments, and you use this container to host your development environment and connect from the container to those services. And then there's yet another thing, which you could say is like remote or cloud development environments. Cloud development environments is a very common term. So you don't host this on your machine, rather you host this in a cloud, your on-prem, a machine, your home lab, somewhere else, not your machine, and then connect via SSH or HTTPS to those development environments in the cloud, which then connects to the services. So there's like a few pros and cons to do conceptually to do those things. For like the right side of the picture, remote and cloud development environment. In Germany, a lot of innovation is driven by anxiety. So a lot of companies that actually want to do this because of security concerns, because of governance things. So this is like one way to look at this. but also just the term that rises a bit with platform engineering, developer experience. That's a neater way to manage this, and maybe also make development environments as a service. So if you work on a new project in your company, or you onboard like new members, they don't have to go through setting up their machine 2 weeks and then it crashes, identity replacement, and then everything is lost. So yeah, but why? There are heaps of our positive things to say about development environments. One thing which is for me like one of the biggest reasons is like your life cycle. So if you develop your automation and then you have like a pod instance which runs a completely different Ansible version with completely different dependencies, with completely different collection versions, that's most likely will not work. This one reason, so this complete set of having reproducible development environments have like standard, have like some kind of governance. You could theoretically and practically have like your development environments as code and align those with the life cycles of the things you automate against or of the Ansible versions you use in production. I talked about faster onboardings, I talked about lifecycle challenges. And another thing is, this is often what gets overlooked quite often, is that it's not just hosting the developed environment itself and having this as code, but also having the possibility to use prod-like infrastructure on your local environment. So, for instance, a lot of network appliances come as a container image these days, so you can use this container environment images to host like your Cisco Acer or I don't know what, and automate against this without actually having this network appliance physically. And other dependencies you may have like in a big production environment, like secret management, HashiCorp Vault, Networks as a CMDB, IPAM. You can also abstract this on your local machine and run those containers locally. So let's look at the anatomy of an Ansible development environment. This is very opinionated. So what would I put in there? First things first, the Ansible content developer, an IDE in terms of we want some more features than typical just plain text editors have. Then things like Ansible development tools, who uses Ansible development tools? Who does not know what Ansible development tools are? So it's basically a single way entry point to install all the tools you basically need to develop Ansible content. And the good things about this is its version, so it makes sure that your Ansible core version definitely works with the Ansible lint and molecule version, and you don't have like version conflicts within your Ansible development environments, which is for me the biggest selling point of using this. Then you need some form of LSP, in this form Ansible language server. Who uses the Ansible LSP? Okay, who uses the Ansible VS Code extension? Okay, perfect. Then we will look at the LSP as well. You need the collections you actually want to write automation content for, because without the collections, the LSP knows only so much, but we will look this at the demo as well. And, which is for me is optional, but test-driven development capabilities, because a lot of people don't actually do test-driven development with Ansible, and the collection dependencies if you actually want to run this automation from your development environment, because in like large environments you often have to case this Ansible content you develop is never actually run on the machine, but rather pushed into a Git and then run in CI/CD or AWX or AIP, something like this. So, because there was a lack, show of hands, for language server protocol, what is language server protocol? So before LSP, every text editor, every IDE had to develop an own kind of plugin to integrate certain language specific features, which was not good because it was very IDE dependent if this IDE supported a certain language you wanted to write well. Then Microsoft came along and started to develop LSP as a standard with CodeEnvy and Red Hat. And today that's the standard and language intelligence tooling. So now you only need one LSP for a language, and then all of the editors can just integrate this LSP as language intelligence tooling. So you have features like syntax highlighting, validation, linting integration, auto-completion, doc reference, all of that kind of stuff, and it actually gives you superpower to develop. Let's look at LSP in action. Oops. So let me just open a playbook, and I'm showing this in Vim, but this actually uses the same LSP that you would use in VS Code. So here you see I'm just starting to write some random playbook, and when I write with control space, it gives me all the Ansible collections that are installed there. So if I want to write something against HashiVault, it would list me this, and if I wouldn't have to zoom all the way up, I could actually read some documentation and see how this module is used. Is this the module I want to use? So I don't even have to look it up in the docs online. I can let's just take this one. And then when I have the module, I can just look at, oh cool, what properties does this thing have? The first thing I see, oh, it's required, I need a path. I need things like URL, proxies, all kind of stuff. I can read through this. And other great things are things like if I start using this within my system, it also tells me, oh, you want to define a variable path, there's only one variable you define so far, so you don't have to type that out as well. So you're really fast developing all of this kind of stuff. And what I can actually also do is it also highlights me if I write rubbish that would probably crash something or won't even run. That's one thing. Another thing is that I know that this needs the path as like a definitive thing, and now I'm getting the message, oh, missing required arguments path. You have not defined this argument which is required. This is one thing to look at it. Another thing is, which is also getting overlooked quite as well, you can jump into the definition, to the very file of the module on your system, like this. And there is your documentation. You don't need a web browser anymore. And what you can also do, you can just do things like copy this thing out of the example, back in your playbook, and there's your example. No context switch, no Slack email messages to check on the way. So it's kind of a very neat workflow. So I propose, if you haven't used Ansible LSP, start using Ansible LSP. It's really, really beneficial. And if I knew this sooner, I would have used this very soon. So, perfect. Back to the topic. So, so before development environments, there were ways to manage your environment, but there are more standards now, and there is actually like a more declarative way to do this. One of those standards is development containers, short for dev containers, and it's more than one thing, which is a bit complicated. So it's first of all, it's a specification, it's a standard. You see here, I hope you see this in the back. Maybe we'll just you see it. It's just, I know we are at Cfgmgmtcamp, but it's JSON. I can change it. This is just a specification of how this development environment should look like. It has a name, it has some things like an image. In this image, there's all the software dependencies like the Ansible dev tools we want to use. There's some runtime arguments about how we actually spawn a container. And there's things like customization, so we can also customize VS Code extensions we want to use. or also VS Code settings we want to set. And this is actually also part of the Ansible DevTools repository. So if you go up there, there's examples for how you can use dev containers and the specification and images that are getting updated quite frequently. So, as I said, it's a declarative definition of software dependencies, IDE dependencies, and runtime dependencies. And there's a lot of different tooling around dev containers. So there's like an integration for Visual Studio, Visual Studio Code, all the JetBrains IDEs, CLI, and a lot of tools for building on this specification, which we will also look at later, like DevPod, for instance, or Gitpod. And there's also Microsoft doesn't only do this for Microsoft's sake. There's also like an SaaS solution if you use GitHub or if you use GitHub Enterprise. There's like GitHub Codespaces. There's like online hosted dev containers for you and your projects. So let's look at this a bit more detail. What actually happens? So you need your machine with your VS Code. We will look at the VS Code extension, Docker or some kind of OCI container runtime, and preferably SSH. And the extension dev container takes care of the complete lifecycle of your dev environment. So if you have no Docker knowledge whatsoever, it actually completely abstracts that. You spawn the container, you can rebuild it, you can pull all the images and even build the images without even seeing that this happens. It just does this for you. And then what your IDE does, it's SSH into the container. And of course you want to use things like your Git credentials, you could, and also the Git credentials helper are getting forwarded, or your SSH agent are also getting forwarded in the container. So you can use this, and it doesn't feel very different than using your normal IDE, your normal development environment. So, one thing I mentioned, you can create one or more containers. So in the example, it pointed to one image. It can also point to a compose, for instance. So you can spin up several images at once if you have, like I said, a network appliance you want to spin up and automate against this network appliance. There's also advanced features like templates. So if you use this quite often, you can use templates to bootstrap your dev container projects. And there's a thing called features, where you can also share dev container code with other people in a feature font. Perfect. How does this look like? Subtle foreshadowing. If I start my VS Code in a project that has this .devcontainer.json file in it, it will just start up, and then there will be a little pop-up. Oh, it seems like you have a dev container. Reopen a container, and now what it does is just reopens the container. It was that simple, actually.
Could you zoom in a bit, please?
Excuse me?
Zoom in a bit.
Sure. Yeah. So
Thanks.
there was this little pop-up here which told me like, please reopen this in a container. It's like a .dev container JSON in this, and that's what we did. So now we're running this in Docker on my machine. You can see I have all the Ansible development tools I need, and what I also have, I have the Red Hat Ansible extension and can use things like LSP and all that kind of stuff. So what I did here to show a difference about this, I didn't point directly to the image, but you can also point to a container file, and that's a very small container file. But what it does, that's also installing collections on top of the DevTools, so that I can actually see the like we looked in the NeoVim example, you can actually look up all the collections we want to use with the parameters and use all the LSP functionality. And what's also very neat, if I start changing this, yada yada, it's not very important. So if we change anything about this dev container JSON or container file, it prompts us with, oh, it seems like the configuration file has changed. Let's rebuild this for you. And now this Docker image, in this case not a Docker image, but this dev container gets spun up again with a different name. And I can also, if I would have changed anything like more dramatically, like for instance, add another extension, this extension would have been installed. So it's really, you don't really have to deal with Docker at all. Other quite interesting things is it is very tied into this remote functionality of VS Code. So here you can see that these extensions are installed in your dev container and not in VS Code itself. Perfect. So that's dev containers, pretty simple. But there's also some open source controversy, and when you hand in a talk to Config Management Camp, there's a little sentence saying all presentations must be about truly open source software, and VS Code is not truly open source. So what Visual Studio Code does, it installs packages from Visual Studio Marketplace, and actually all the other kind of open source alternatives to VS Code install packages mostly from OpenVSX registries. Has some things to do with like with license and agreements with Visual Studio Marketplace, and also a different thing is this. Although there's a GitHub repository with VS Code, this VS Code is built on this open source, but the actual binary download and use is not open source available. So Microsoft bakes in some telemetry and published this under a proprietary Microsoft license, which is also not open source. Just wanting to point this out because this afflicts all the other tools we will look at because they handle things a bit different and things are not easily integrated if you want to use truly open source alternatives. And the biggest part is that some extensions are not available. If you use something like Codium, which is like an OSS built from source, from the VS Code sources, and the remote management and development extensions which you use to use dev containers or which you use to SSH into a system from VS Code, this is also not available in like the OSS alternatives. So if you have VS Codium, for instance, and you want to use dev containers like now, it won't work. But there are alternatives. One of those alternatives is DevPod, which does things quite differently actually. So this is like a desktop client for managing development environments anywhere, so locally but also remote. And the way this works is there is integrated providers to deploy those dev containers on your infrastructure. Those providers are written in Go, and they provide capabilities to deploy dev containers on Docker, SSH, Kubernetes, and all kind of public cloud providers. And if this doesn't suit your use case, you can also integrate custom Terraform providers that deploy this dev container on your infrastructure needs. But what it does is supports dev container specification, which is really good. So if you're moving from the first use case to this, you can just lift and shift. There's also an enterprise version of this. I haven't looked at it, but it seems to, there's like, I think a closed beta even, it gives a little bit more capabilities in terms of sharing those templates, those dev containers with your team. And there's a doc files integration if you care. And some community member even wrote a Codium plugin to allow like a VS Code-like field. So you open this and it prompts you with, oh, it seems like you have a dev container, do you want to open this in DevPod? And it does that for you. So if we look at DevPod, it's this little application. I can also zoom, I hope, extra large, nice. So that's DevPod. Here we see our workspaces, so our dev containers that are currently running. We can see our providers are only configured Docker, but I could configure all heaps of other providers here. And there's like a lot of settings and customizations to do here. And what is really interesting, if you create a new workspace, this is the range of IDEs you can choose from. So DevPod USP is really if you want choice in your IDEs, it can provide it. And if we spin up this container right here, this is not VS Code, this is Z, which is like one of the new cool IDEs. It just SSH into this dev container from Z. So most of the new open source IDEs are having almost the same kind of integration. What it doesn't do actually is having the LSP available, but that's the Z thing. Yes, so that was dev containers. Let's look at Gitpod, and I have to admit it's kind of a weird time to look at Gitpod because they had a very established product for a very long time, which was competing a bit with the dev container standards. They now call this Gitpod Classic. This will be end of life this April. And it was basically like a software as a service offering, including a .gitpod.yaml spec. But now it seems like they lost the races. I don't know the reasoning behind it, but they're now implementing this dev container spec in like a new fleet of products, being it Gitpod Free, Flex, or Enterprise, and it's let you essentially manage this dev containers in local environments, but also self-hosted in your cloud. So this is like if you remember the conceptual part, it's kind of a local environment, but also like cloud development environment solution. And the USP for Gitpod is that this management plane, you don't have to host yourself. This is hosted by Gitpod, but your workloads are hosted by yourself. And so you don't have to care about the life cycle of this management plane. And you can also like onboard your colleagues and work together on different kind of templates with your colleagues. There's an early access of Gitpod Flex. I have to say it came with some flaws. One of the flaws was performance. The other flaw was when this container was spun up, it didn't use Docker actually directly, but it spun up a virtual machine and then uses the Docker of this virtual machine. And it uses Rosetta virtualization for some reasoning, so it was incredibly slow the first time I started machine. Although it implements the dev container spec, you don't have this, what we looked at, you don't have the integration into VS Code extensions, which is kind of such. But it takes some things a bit further and adds features like automations and sharing projects with your team. So let's look at this in practice. So I hope this is large enough. This would be just like the Gitpod tool itself, which is very similar to DevPod. You can have your projects here and stop them, run them. You can have things like auto stop after a certain time, all of this kind of stuff. And you have kind of like a task running engine, you could call this. Maybe you know task file. So this abstracts tasks you run on a regular basis. And how this looks is that there's also like VS Code extensions for it itself to manage these environments within VS Code. And there is this automations.yaml. And this automations.yaml, you can share tasks that you would run on a regular basis. Maybe your colleagues don't know about the Ansible and autofix feature, so you just put this in there and be like, before you push this code, remember to use this automation. And then you can just run those automations within either your IDE or also via the client. So you see here is like the automation panels. And what it now does is just run Ansible autofix, and if I had made some mistakes, Ansible knows how to fix. Oh, cool, it doesn't work. I had to, because we're demoing live. Let me see. There's something wrong. Oh, okay, it didn't work because my linting didn't work. I mean, that's good, right? So one syntax check failed. 1 failures, 0 warnings on 7 files. I won't fix this right now, but here you would see did this succeed, what happened. Of course, for Ansible, this is not like the most useful feature, but if you have like, if you're developing software and you have like build scripts, you can abstract this with those like task engine. So that's for GitPod. Let's look at Coda. Coda, maybe some of you people know Code Server, like the VS Code style thing you can install on the server and then log into this. Coda are the makers of this product. This was way before Microsoft developed VS Code Server. And they have also now like a cloud development environment tool for some time now. And the idea is that this is a more controlled environment, so you probably have some Coda administrators that are creating templates, and then your developers can consume those templates also in some kind of workspaces. And this all runs on Coda Server. So this is more like you don't have dev containers per se. It's like a Terraform-driven templates. And you can spin up everything, not just containers. Be it VMs, pods, containers, whole cloud services, everything you basically can deploy via Terraform. It is very much like other single Go binaries, so the binary of Coda is the server as well as the client. You just need some PostgreSQL database, and you can pretty much run this very easily and basically everywhere. You can consume the workspace via IDE, Web IDE, or a Web SSH channel we'll also look at. And there's also heaps of enterprise features like high availability, scalability, and like advanced networking security features and lifecycle features. We will also look at this. Perfect. And there's also integrations like into your secret management, so that your developers don't need to or are not allowed to enter secrets in some menu form, or that if you want to use images from Artifactory, for example. So let's look at Coda. This is Coda. I will zoom in a bit. And this is how you will get greeted as a developer. So here you see your workspaces. And you can create new workspaces and consume them right away. So I spun those up already, and what you can see here, this is how a workspace looks. Don't look too much about this latency thing, which is actually a great thing because latency is a very good metric with those cloud development environments if this is actually usable and feels good. And what I did here, you can install Coda very easily. And if you don't configure it otherwise, it will spin up like a test environment and then proxies your whole networking over Coda servers. So you can install this on your machine, but then consume this like from everywhere from the internet to just try out how this feels, and that's why the latency is so high. And here I have my Ansible Development Environment, and I can do things like go into this in my web browser, just typing and consume this right away and write Ansible code. So what this does, just close the terminal. I can also open this in a Coda server if I maybe log in from a machine that doesn't have VS Code installed, or I can open this in VS Code desktop. And what you also are seeing here, that there is, it's actually very performant in deploying those resources. And you can also see the resources that are consumed right now. So this is my workspace. This is my image. This is a dev container, which I will go into more detail. Yeah. The thing with Coda is it supports dev containers, kind of. So there's a tool called Coda Env Builder, which is built into this. And this kind of is a bit of an abstraction of dev container lifecycle stages. So in the dev container JSON spec we looked at, there's things like if this container starts, do this kind of script, and Coda doesn't support this, so but you can just give it a dev container and it will build a new image on top of this dev container definition, which is basically an F builder, so Coda can handle this. Another thing is there's no integration to automatically install IDE extensions, so you can install those in your client IDE or via Coda scripts. But we can also look at how this looks like. So if you like an admin and you administrate this template looks a bit like this. So this is basically just Terraform. And this basically just deploys this Docker container on a Docker host and does some kind of stuff. But the thing is, with using Coda, and using this env builder, Coda manages things a bit different in terms of extensions. So if you want to use the Red Hat Ansible extension, for instance, you need to have this script part in your Ansible extensions, in your Terraform, to actually install this by hand. So I don't know, I don't love it, let's just say it like that. To tinker around and write scripts in your Terraform, it's like, for me, it's not the ideal way to handle with this, and then it's only available in what we looked at the workspaces. It's only available in the code server, not like a VS Code desktop. So it's a different way to do this. I'm not here to judge. So, like I said, traditional Coda templates are completely defined with Terraform. They're using the dev container spec more for the image behind this, not really for other things like extensions. That's about that. So let's talk about the next and last tool, I promise, which is Eclipse. So Eclipse is a Kubernetes-based cloud development environment, which is based on a different specification than dev containers, which is called DevPod. And basically, you can have any kind of Kubernetes infrastructure, preferably OpenShift, because they're like developed by Red Hat, but also Minikube, EKS, AKS, and then you have a user dashboard where you can log into and spawn your user workspaces from one of those dev file definitions. On the other examples, we could always consume this via our IDE installed on this. This is not really possible with that. So, but maybe this is also wanted if you are in a very highly regulated environment and actually don't have VS Code available. You can log into a virtual desktop, for instance, and then just open this page and you're ready to go and to develop. What this also does, users are not only getting a dev environment, they also get like a complete Kubernetes project namespace and can consume Kubernetes resources while developing. So you see this is a very cloud-native development use case, but it's also well suited for test-driven development with molecules. So you can spin up pods that replicate some kind of different server versions and operating systems you want to automate against. So this is also a very, very cool test-driven development use case. There's an enterprise version of that called Red Hat OpenShift Dev Spaces. This is formerly known as Code-Ready Workspaces or CodeEnvy, which was like the company that Red Hat acquired, I think, back in 2017. And if you want to try this out, it's actually pretty easy to install, but there's also Red Hat developer sandboxes. So if you have a Red Hat developer account, you can just click your sandbox and try this out in this sandbox. Oops. So let's look at Red Hat OpenShift Dev Spaces, which is, like I said, the enterprise version of this. So we can just consume our workspace or can just spawn new workspaces. And what it does is deploying this workspace with an operator in the background on OpenShift, and opens the web IDE for us. It's a very integrated OpenShift look and feel. Perfect. I will also zoom in here a little bit, if I may. Good. So, the dev file.yaml is already open, so this is not dev container spec, but a different specification targeted to this tool. And we can see it's in some ways it's pretty similar, that we have like several components. We can create like a tooling container, and this is also just an example from the Ansible Dev Tools project. So don't only go there to use the dev tools itself, but also to use some of those things. And what you can define is also some kind of task engine. So you can define tasks to interact with the molecule resources that are in this example. So this is also an abstraction level so that you can collaborate on those actions and make it easier for other people to use this. So what we can do, we can look at the pods that are running currently. So it's just this workspace, but we can also deploy new resources within this workspace. And the cool way to do this is via just defined actions that I just told you about. So if we can, if we do one task in this VS Code instance, we can see this. There is like dev file task, and we can have some explanation of what this actually does. Start a test pod for the automation, and in the background we have this all defined in here with molecule. It will just deploy a new pod with a Red Hat UV image that we can run our test-driven development against. So perfect. If we run also get pods again, we see that there is a molecule UVA Python container that just spun up, and then we can do things like run different tasks to, for instance, apply the role to this pod, or just run a verification at the pod. And this verification will of course fail because we not yet ran our role against this. But this is just a brief overview of how you can use this. And yeah, thanks to Red Hat, actually we didn't have to do anything to this demo, because this is all publicly available resources and code. Perfect. Let's talk about some common enterprise features. Because they all share some kind of features. There's a lot of things like scalability and high availability. There's things like pre-built environments, which is pretty interesting. So if you do a pull request and you change things on your container spec or something like this, then other people within the pull request can just click on, oh, I want to look at this pull request in a dev container that already spun up with all the changes made. And I don't have to configure my own or spin up my own container to look at these changes. But be honest, like a lot of code reviews get done by just looking at the code and not actually testing it within your IDE, within this environment. So that's a big feature. You have things like scheduled downtimes and availability. You can spin up instances if you know that all your devs start at 9 and spin them down. You have things like template versions that we can actually look at in my Coda example, which is pretty interesting. So this is a few of the templates I try to do, and one template, which is called Top Secret, I tried actually to play Doom with you in the terminal, but I didn't get it to work, so there's that. But with that we can also see the versions that I created for this. And with the versioning, you can do things like promote new versions and assign tags, and then the developer would get a notification which is like, oh, there's a new version of your currently run in production Ansible version. You may want to update your development environment to reflect those changes. And Other enterprise features include things like force your devs to use this new development environment. There's things like metrics and telemetry. You can see what is actually used and how, with access control. You can actually use this to onboard contractors from outside that don't have to have like your infrastructure, your notebooks, a lot of governance things I already mentioned, and things like, of course, support and SLAs. Perfect. So let's talk about some entry points to interact with development environments. We talked about IDEs, we talked about web portals, CLIs, and desktop clients, but there's more. Gitpod actually has a browser extension you can install and then just open everything you see on gitlab.com or gitlab.com within a Gitpod container. There's things like markdown batches you can maintain in your repository to open this directly in your CDE. There's things like merge requests, what I already told about, and if you focusing on like a platform engineering use case, you can also integrate this with internal developer portals. Perfect. Let's talk a bit about a comparison of supported IDEs. So DevPod takes it all because it supports all of those. I try to do a bit of categories. You basically have VS Code or Open VS Code versions, all the JetBrains IDEs that work very well with this. You have the cool kits. From what I heard, I'm not using those. It's that and I think Cursor, which is like an AI-powered IDE. I don't know. And Fleet, which is like the new IDE brainchild from JetBrains. And you have data science IDEs that also support this. Then you have Coda. Coda doesn't support Codium and Dataspell from JetBrains. Not Cursor and only Jupyter, if you care about data science. Then there is Gitpod, which actually supports a lot of this, but not the data science ones. And then there is Eclipse or OpenShift DevSpaces, which only supports VS Code and IntelliJ, but I think the community edition of this. So there was a time where more was supported, but they kind of don't support so much IDEs anymore. Perfect. Let's look at the infrastructure point of view. So with development containers, it's very IDE dependent because dev containers itself is not like a solution. It's just like a specification and implementations in IDEs in VS Code in the CLI. So it's a very IDE dependent way you run those, but you can run environments on every OCI container runtime. DevPod is a local client, but you can run environments everywhere, especially with this Terraform integration. Gitpod, you have like a management plane in the cloud, but you can run environments locally and in cloud. With Coda, you have like your Coda server, which is you can also install everywhere on your machine, on a server, in Kubernetes, in a container. And due to the Terraform integration, you can also use those environments everywhere. And with Eclipse, both the workload and the management run in Kubernetes. Perfect. Let's talk sweet spots. So I've tried to use all of those in some way, and all of those like fit the solution of the problem they try to solve, just that they enable you to use reproducible and shareable dev environments with your colleagues or your communities. The first three are very easy to get started due to their nature, and like Coda and Eclipse, they are more like for large-scale operations. If you want to enable hundreds of thousands of people to write Ansible for your organization, for instance. And those tools also have like are very designed to have high governance and all of this security features we talked about. So where do we go from here? Some closing thoughts. From what I've seen within the last year, actually last year pretty much on Config Management Camp was also the first time I heard about development containers, and a lot of open source communities and repositories are using that as of right now to basically have like a declaration of their dependencies and make it easy for you to contribute. So all of us know the pain of run this makefile on your machine, and maybe you can contribute to our project, probably not. Ansible DevTools is the go-to repository entry point, not just for tools, but also to find things like this, the Eclipse Beispiel or the dev container example Beispiel. And there's a lot of movement and innovation which we all benefit from. So there's a lot of new different tools surrounding cloud development environments. This is very much driven within like the cloud native community, but there's also heaps of new IDEs like Z, like Cursor, like Fleet, which are coming out. Which is, I mean, it's always good to have some competition against companies like Microsoft. And one of the things is, I mean, I advise clients from all walks of life, but like AI coding assistance is also a thing, and this is a solution to actually roll this out and integrate this for like whole enterprises. Because when I talk to clients, they often say, no, our developers don't use those AI coding assistants. And like, yeah, you bet. There probably are. So this can be a solution around that to enforce what coding assistant and to allow it that like coding assistants are not training on your company's code base, basically. And which I'm uncertain about because CDEs is not a new thing in any way. The development of those tools started 10 years ago. But what also happened in the 10 years that compute power on like mobile computers got faster and faster and faster. So maybe there is like a hybrid solution in the future in the likes of DevPod where you run this locally, but you can also share the templates with your teams. So it depends on the use case, but I think that's most likely what it will be. Perfect. And don't miss out on 2 talks that were already today. I don't know if they're even call it, but Ganesh talked about the Ansible Creator experience, which fits in this topic. Soren talked about Beyond Copy and Paste, about DevTools as well. Tomorrow, Soren also has a talk about Ansible content, and on Wednesday, like mentioned several times today, there will be an Ansible Development Tools workshop. Basically. And there's a lot of people that would like to hear your feedback. I'm also just a user, but there's like someone who's like lead for the DevTools. There's Tim Abner, who's like product manager. So if you have your Red Hat folks here, just hit them up, and if you have any complaints or needs. Perfect. Any questions?
What would you say are the most common pitfalls for people starting out with dev containers? The dev container part of this whole...
The dev container part? The most common pitfalls, don't overthink it. Like, it depends what you want to do with this. It gives you a lot of power, but it really depends on your workflow. Maybe pin your images to have certain versions of tools you use. Maybe you're running problems because you're running on latest. It really depends on what you're automating against, what your colleagues are using. But I think the biggest pitfall, at least for me, it was not starting with it, knowing that it exists and not starting using it. And if you work in large teams or organizations, your colleagues won't care that that is a .dev container.json in a project, just start using it.
By the way, you mentioned an earlier presentation that happened this year, and there was a comment about, or rather, there was something in the slides about EE minimum container image that could be used, and I noticed that you use that. I'm not sure if it was a choice.
Oh, you mean to use execution environment images instead of the DevTools?
No, as in the image that the container was built on was the EE minimal
Yes.
image.
The base image for execution environments. it's a valid choice.
Just wondering if there was any thought behind it, or it just didn't happen to pop up during the presentation.
No. What you can actually also do is just align this with like your execution environment lifecycle. So if you build an execution environment, use this as your like base image for your dev containers, and you don't have to care about other stuff like installing collections or not having the dependencies to run those. Perfect. Thank you so much.